Today, as the PV industry shifts towards quality-driven growth, the value of solar modules is being redefined. The market is increasingly focused on whether modules can deliver higher and more stable returns in real-world applications. This is why independent third-party validation is essential to evaluate technology under real operating conditions, not just under laboratory assumptions. For LONGi BC technology, these validations help demonstrate how advanced module design can translate into real-world project value. Across Europe, LONGi has worked with leading independent institutions to evaluate BC module performance from multiple perspectives, including outdoor field testing, rooftop scenarios, shading response, system-level economics, and application-specific value. Each institution contributes a specific layer of evidence, helping connect module-level innovation with measurable value at project level. At the Spanish National Renewable Energy Center, CENER, the study focuses on representative partial shading scenarios commonly found in real power plant conditions. Here, BC and TOPCon modules were tested under identical shading conditions for comparative evaluation. Samples simulate various typical working conditions, including moving shadows and changes in shading ratios. Thermal imaging shows that the temperature rise in shaded areas of BC modules is slower, resulting in lower power loss. The results indicate that BC modules have a more optimized current transmission pathway under shaded conditions, significantly reducing power loss. Inside CENER's testing facility, researchers conduct systematic analysis of the collected test data.
Under fixed shaded, designed to simulate a cell being fully shaded, such as by a leaf, the back contact module achieved more than 30% higher instantaneous power than TOPCon under high irradiance.
These results support the long-term value of BC modules in shared scenarios. At the Italian National Agency for New Technologies, Energy and Sustainable Economic Development, ENEA, the study focuses on space utilization and shading issues in real rooftop scenarios. Rooftop space is limited, and architectural shadows from stairwells and outdoor air conditioning units can cause real shading on modules. As the solar angle changes, building shadows move across module surfaces, creating dynamic shading. Thermal imaging indicates that under shaded conditions, BC modules exhibit more uniform temperature distribution and lower power loss. At the same time, on a per-watt energy yield basis, BC modules demonstrate superior energy output. Within the same module installation area and under identical environmental conditions, BC modules achieved a 3.78 increase in installed power capacity and a 4.17 increase in first-year energy yield. Related research from Germany's Fraunhofer ISE further validates the potential advantages of the BC structure from the perspective of fundamental technical mechanisms and system efficiency. The studies indicate that the back contact structure effectively reduces front-side shading losses while optimizing carrier collection paths, allowing modules to maintain high energy conversion efficiency under complex environmental conditions. In collaboration with Enertis Applus, LONGi conducted a comprehensive analysis and simulation of different module solutions for utility-scale PV projects in Spain. Enertis Applus analysis shows that high Mo9 modules achieve up to 3.4 higher first-year per watt energy yield compared with TOPCon modules, while also demonstrating a clear advantage over HJT modules. Meanwhile, IPVF research further confirms that even with a module price premium of $0.01 per watt, BC modules can still achieve a more competitive LCOE through higher energy yield. LCOE advantages exceeding 3%. These results demonstrate that the value of BC technology is reflected not only in increased energy generation, but also in full life cycle economic optimization. For real project validation, TÜV Rheinland conducted system-level evaluations in Southampton, UK and Skalstrup, Denmark. Under two typical design conditions, equal DC capacity and equal land area, HIMO 9 modules achieved higher first-year energy output in both cases. At the same time, assuming the same module price, project CAPEX was reduced under the evaluating scenarios, while long-term OPEX also showed a downward trend. Overall, project LCOE was optimized by approximately 2% to more than 3% across different scenarios, corresponding to a significant improvement in system value. This indicates that in real power plant investments, BC modules can directly translate into more competitive results. From laboratory validation to field project evidence, from the European market to global application, LONGi BC modules are continuously demonstrating their performance stability and system value advantages in complex scenarios through a multidimensional, cross-regional third-party validation framework. LONGi, driving the long-term value of every kilowatt-hour through technological innovation.
LONGi.